Most modern-day smartphones make it almost impossible to modify anything related to hardware. At best, doing so requires advanced soldering skills, and even if you're using the USB port, that port will not provide any strain relief. Pine64's PinePhone is an exception, and it will give you easy internal access to a common interface known as I2C, or Inter-Integrated Circuit. Last summer I bought the PinePhone Beta Edition, version 1.2b, and more recently I've purchased a second phone outright. Along with the secondary phone, which I use for experimentation, I have also purchased the official Breakout board for the I2C interface. This is an ongoing project, but today I'm going to share what I think of this Breakout board. First off, special thanks go out to everybody who submitted follow-up questions for the previous videos. This is a small channel with limited resources, and it is not made for the YouTube algorithm. And because of that, I'm posting everything early to Minds.com, Odyssey.com video, and of course my own website. That is also where I'm posting all the details from this video, including all the voltage measurements from when I first used this interface. As far as I know, this only applies to PinePhone versions 1.2, 1.2a, and 1.2b. The PinePhone Pro is outside the scope of this video, but only because I haven't tried it yet. For today's setup, I charged up the battery to about 90–95%. I've powered off the phone, and I make sure to remove the battery before making modifications. If you have not seen the original unboxing, just know that the manufacturers made the back cover easy to remove. Just be sure not to overbend it. The I2C interface can carry a variety of messages, but compared to USB, this is a lower speed. The purpose of the Breakout board is to give us easy access to 6 nodes inside the system. GND, or ground, is the 0-volt reference for the entire phone. SCL and SDA are part of the I2C interface. As best as I can tell, you can expect these to be 0 volts when the phone is turned off. Otherwise, expect them to idle at 3.3 volts. And this idling voltage is due to a 10K pull-up resistor. On the Breakout board itself, both the SDA and SCL are labeled I2C, but the SDA pin is the one in the middle. The DCN node appears to be related to USB charging. When the phone was not charging, this was 0 volts, and when the phone was charging, the voltage was 4.8, which is inside USB specification. And by the way, this happened regardless of whether the phone was turned on or off. The USB 5V node appears to be related to the battery. When the battery was installed but the phone was not charging, this node was about 4.1 volts, but when the phone was charging, it was 4.7. Out of all 6 connections, this was the only one to provide voltage as long as the battery was present. Finally, there's the INT, or interrupt pin, and even though it has the same idle characteristics as the I2C pins, I could not find a lot of information on what it does, or whether the pin is a input, output, or if it's bidirectional. The far end of the Breakout board has 6 connections in total, 1 for every signal. These are spaced out 100 mils, or 2.54 millimeters apart, so it's able to work with a lot of other connectors. And again, because the phone is providing those pull-up resistors for the I2C interface, you can measure waveforms directly from this position. Simply remove the 2 original mounting screws, orient the Breakout board so that the gold contacts are facing down towards the phone, align it to the 2 holes where the mounting screws go, and then fasten it down with the 2 screws that came with the Breakout board. When you handle this system, just be sure not to short anything, and just keep the contacts as clean as possible for a good connection. So I'm just now getting started using this system, and it matches the documentation so far, but the contact resistance is a little bit higher than I'd like it to be. You can address this by putting something rigid behind the Breakout board, and that rigid surface is going to exert enough force to keep all 6 connections in good contact. If the voltages you're detecting are substantially lower than the ones I reported, there's a good chance there's just not a good contact. Now, if you're more interested in the other serial connection, you can check out RTP Privacy and Tech Tips, who is also sharing valuable information about Pine64 hardware. The PinePhone itself also features a Universal Asynchronous Receiver Transmitter, or UART, and even though you need to flip an internal switch to use it, it will give you access to the shell, sort of like the console does. Before I go, I should also mention that this internal connector is also used by the official keyboard and the official LoRa mod. Presently, both are in my inventory, so if you prefer to see one before the other, let me know in the comments and I'll see what I can do.